Hello students, in this video we are going to correct exercise page 119 number 4. This is the figure that we should construct for this exercise. Let's see how we should do the construction. From the extremity A of a segment AB, so first we draw a segment AB. Since the length is not given, you can draw it as long as you want. Draw on both sides of AB two rays, two semilines, AX and AY, such that angle BAX equals angle BAY equals 50 degrees. So we need to draw two semilines, AX and AY, on both sides of AB. It means one of them should be above and the other below segment AB. For example, here I chose to draw AX above segment AB and AY below segment AB. So we draw a semiline AX such that angle BAX equals 50 degrees with my protractor, and I draw semiline AY such that angle BAY equals 50 degrees. Similarly, from point B, draw two semilines BU and BV also on both sides of AB, such that ABU equals ABV equals 60 degrees. AX and BU, which are on the same side of AB, so I have to draw BU on the same side as AX. Since AX is drawn above, I draw BU also above segment AB, and BV also, which should be on the same side as semiline AY. So I draw it below, such that angle ABU, so I draw angle ABU of measure 60 degrees and angle ABV of measure 60 degrees also. AX and BU will intersect at point M, and AY and BV will intersect at point called M. So here we have this evidence, straightforward evidence. BAX equals BAY equals 50 degrees each, and ABU equals angle ABV equals 60 degrees each. First question, show that the two triangles AMB and ANB are congruent. So for one, show, underline, AMB and ANB are congruent. Proof. So first we start with the introduction statement. We write in triangles AMB and ANB. Then we gather the three evidence needed to prove that they are congruent. So let's see in the figure. We noted that the two triangles AMB and ANB, in their name we have these two repeated letters, letter A, B, B. So we notice that segment AB is a common side of these two triangles. So we found our equal side. Now we need to prove that the two angles adjacent to side AB in triangle AMB, which are of vertices A and B, are respectively equal to the two angles adjacent to side AB in triangle A and B, which are also of vertices A and B. Here, by looking at the straightforward evidence given, we can claim that angle MAB equals angle BAN, it's given, and angle MBA equals angle ABN given, and these two pairs of angles are adjacent to this common side that we claimed. So we found our three evidence. AB equals AB, common side. Angle BAM equals angle BAN equals 50 degrees, it's a given. And angle ABM equals angle ABN, it's also given. Now we need to write the congruence statement in the end. triangles A and B are congruent by one equal side included between two equal angles. So remark, don't forget to write the congruence statement. We don't stop here. If we don't write the congruence statement, our answer is incomplete, so be careful. Now question 2. Prove that the line AB is the perpendicular bisector of segment MN. Prove, underline, AB is the perpendicular bisector of MN. So don't forget to write the question first. Here, to prove that a line is perpendicular to a segment by definition, we need to prove that it's perpendicular to segment MN at its midpoint. But here, since this perpendicular is not constructed, we have no information about it, nor about the midpoint of MN, so we need to find another method. And as we learned in our 8 parts video, to prove that a line is perpendicular to a segment, we can use the converse of the perpendicular bisector theorem. We need to prove that points A and B are equidistant, are at equal distance from the extremities of segment MN. If we prove that AM equals AN and BM equals BN, our work is done. So here, since the two triangles A and B are congruent, we can claim that all their corresponding elements are equal. In particular, AM equals AN. How do I know? Because since these two angles of measure 60 degrees are equal, so the sides opposite to 60 degrees are equal. So if you are not able to find equal sides, you can see which angles are equal. So the sides opposite to these two angles must be equal. Same for the two angles opposite to 50 degrees, which are BM and BN. So proof, so first AM equals AN and BM equals BN, corresponding elements of these two congruent triangles that we just proved. Once we prove something, we can use it in the next question. So AM equals AN and BM equals BN, because they have the same reason, we can write it for both at the same time. Corresponding elements of congruent triangles A and B must be equal. That's why points A and B are equidistant from the extremities of segment MN, and as a result, line AB, or the line passing through points A and B, is the perpendicular bisector of segment MN. This is the end of the video. After watching the correction, copy neatly this correction on your math copybook. Thank you for watching.